Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. We are still in section 11, 4.4, L'Hopital's rule, and we discuss now the indeterminate difference, infinity minus infinity. What if you have limit of this form, f of x minus g of x, and when you replace x by a, limit of f of x is infinity and g of x is infinity, so you get infinity over infinity. What to do? Well, usually, of course, you cannot use L'Hopital's rule. So usually you want to convert the difference into a quotient. If you can convert the difference into a quotient, then you will have 0 over 0 or infinity over infinity. Sometimes the denominator, using a common denominator or rationalizing or factoring a common factor. Okay, so let us have some examples. Well, if I replace x by 1, then 1 is 0, 1 over 0 is infinity, 1 minus 1 is 0, 1 over 0 is infinity, so I have infinity minus infinity. Well, what I can do here is to add these two fractions, just using the formula, how to add a over b plus c over d. You multiply ad plus or minus b c. So you multiply x minus 1 times ln x. This is in the denominator. You multiply the two denominators. Then x minus 1 times 1 minus 1 times ln x. And now you have a fraction. Try replacing x by 1 now. 1 minus 1 is 0, ln 1 is 0, so I have 0 in the denominator. 1 minus 1, 0, minus ln 1, 0. I have 0 over 0, so I can use L'Hopital's formula or rule. So I need to find the derivative of the numerator. Derivative of x is 1, derivative of 1 is 0, derivative of ln x is 1 over x. Here I have product. Derivative of x minus 1 is 1 times derivative of ln x, which is 1 over x. So I can write it like this. Also, I have here, this is 1 over x. So I can see that I have x denominators, so I can multiply by x over x to simplify. So x times 1, x times 1 over x times ln x, and x will be cancelled with x, and we will have x minus 1. Now if I replace x by 1, 1 minus 1 is 0, and here ln 1 is 0, so this is 0, and 1 minus 1 is 0, so again I have 0 over 0. So I need to use L'Hopital's once more. Derivative of x is 1, and derivative of 1 is 0. X ln x, the derivative of x is 1, plus x times the derivative of ln x, which is 1 over x. X times 1 over x is just 1. And derivative of this x is 1, and derivative of negative 1 is 0. Now I have ln 1, 0, and 1 plus 1 is 2, so the answer is half. 1 minus 1 is 0, 1 over 0 is infinity, ln 1 is 0, 1 over 0 is infinity. What to do? You add the two fractions. X ln x minus x plus 1, because minus x minus 1, so it would be minus x plus 1. Replace x by 1, ln 1 is 0, minus 1 plus 1 is 0, so I have 0 over 1 minus 1, 0, so 0 over 0. So I can use L'Hopital's. Derivative of x is 1. Derivative of x plus x times 1 over x, derivative of ln x, so this is 1. Derivative of negative x is negative 1, and these two cancels. product. Derivative of x minus 1 is 1 plus x minus 1 over x. Okay, let me multiply again by x over x, similar to the previous example. So I will have limit x ln x, and here x ln x plus x minus 1. Now replacing x by 1, ln 1 is 0, and here 1 minus 1 is 0, ln 1 is 0, so I still have 0 over 0. I use L'Hopital's once more. Derivative of x is 1. X times 1 over x. Same. Derivative of x is 1. Replace x by 1. I have 1 over 2. Cosecant 0 is 1 over sine 0. 1 over 0 is infinity. Cotan 0 is cosine 0 over sine 0. 1 over 0, which is infinity. So what to do here? I have trigonometric functions. What is the definition of cosecant? It is 1 over sine. And what is the definition of cotan? It is cosine over sine. And now I can add these two fractions because they have the same denominator. So I have 1 minus cosine x over sine x. Replace x by 0. Cosine 0 is 1. 1 minus 1 is 0. So I have 0 over 0. So now I can use L'Hopital's rule. Derivative of 1 is 0. Derivative of cosine is negative sine. Derivative of sine x is cosine x. Sine 0 is 0 over cosine 0, which is 1, and 0 over 1 is 0, so the answer is 0. 1 over 0 is infinity. E to the power 0 is 1. 1 minus 1 is 0, and 1 over 0 is again infinity. So let us try to add these two fractions. X times EX minus 1. EX minus 1 times 1 minus x. Replace x by 0. E to the power 0 is 1. 1 minus 1, 0 minus 0. So I have 0 over 0. 0 times 0. I can use L'Hopital's. Derivative of EX is EX. Derivative of negative x is negative 1. Derivative of negative 1 is 0. Product. Derivative of x is 1. Derivative of EX minus 1 is EX. Replace x by 0. E to the power 0 is 1. 1 minus 1 is 0. And here 0 plus 0. So again I have 0 over 0. I use L'Hopital's once more. Derivative of EX minus 1 is EX. Here derivative of EX. Derivative of negative 1 is 0. I have product. Derivative of x is 1 plus x times derivative of EX. Replace x by 0. E to the power 0 is 1. E to the power 0 is 1. E to the power 0 is 1. And here 0 times 1, so it would be 0. And the answer is 1 over 2. Let me give you another example, another exercise. It's exercise 56. It says that limit when x approaches 1 from the right of ln x to the power 7 minus 1 minus ln x to the power 5 minus 1. Find this limit. If I replace x by 1, ln 0 is negative infinity, and here ln 0 is negative infinity. I'll have negative infinity plus infinity. So this is infinity minus infinity. What to do here? Well, with these kinds of problems, I can use the property of len to write len A minus len B as len A over B. I can do it like this. Okay. And now the limit can go even inside the len. And now if I replace x by 1, I have 1 minus 1 over 1 minus 1, 0 over 0. So I can use L'Hopital's rule. Do not forget the len outside. Derivative of x to the power 7, 7x to the power 6 minus 0. Derivative of x to the power 5, 5x to the power 4. This would be len. Now what is this limit? X to the power 6 over x to the power 4. I have 7 over 5 x squared. And x limit x squared when x approaches 1 is 1. So the answer would be 7 over 5 times 1. This is the limit here. So the answer is len 7 over 5. I hope you understand this case now, this indeterminate form, infinity minus infinity.